Dr. Casey, thank you so much for coming in today. It's such a privilege. You have some of the broadest experience in the space industry of anyone, from astronomy at NASA to your heavy involvement in the new space industry. Could you briefly describe your career and background to our viewers?
Yeah, sure, Harry. Well, first of all, thank you very much for having me today. You guys are certainly doing the right thing at Georgetown, and I wish you the best of success in having an impact within this new space community. My own background is that I've always been, focused on physics and mathematics, and so it seemed only natural to go off and, pursue my PhD at the time. Going to college and grad school. So with that, there was also an emphasis on space flight. So after graduating from the University of Chicago, I went to go work at NASA Goddard, where we focused on instrument development, both hardware and software. And then there was a natural progression to work at NASA Ames to support their stratospheric observatory for infrared astronomy, which was their airborne observatory program. And it was a unique opportunity because they were building the facility. It was a 747 SP designed to house a 2.5 meter telescope developed by DLR in Germany. So it was a US-German partnership. But a unique thing about the program was NASA was experimenting with what they call GOCO, a government-owned contractor-operated facility. And at the time, leaving Goddard, you could really see that there was movement afoot for NASA to change its paradigm for how it would do programs. Sophia was an opportunity to really live that, and involved moving to the Bay Area and Silicon Valley. So after working on the Sophia program and being out of academics for a while, it took a bit of motivation to think, hey, gee, maybe I need to go back and get another degree. And I went and got my MBA at the Berkeley Columbia program, which was a great experience. Lots of great cohort, a good opportunity to travel back and forth between New York and the Bay Area, two key financial centers. And, I used that to expand my understanding of early stage companies and finance and, the focus on, what it takes to build various companies. Today, I'm working with Atlas Space Operations, which is an early stage company focused on ground station communications. And, before that, I founded the Silicon Valley Space Center, which was working with a number of early stage companies, some of which are around today and others that have kind of just, faded into the ether. But it's been a very interesting progression from working as an astrophysicist to working business development and sales and, helping build out the customer portfolio for a very exciting company like Atlas Space Operations.
Right. Absolutely. Well, thank you for that. What would you say, in your own words, what are some characteristics of the new space industry, and how does it differ from the firms that would traditionally come to mind when someone would think about the space industry?
Well, what's really happened is that the technology has changed, and we certainly, as you look out for early stage companies, there are a lot of disruptive technologies that, let's say, haven't been adopted by traditional players in the aerospace sector. Clayton Christensen's Innovator's Dilemma is kind of a classic text on that example, where entrepreneurs can take new technologies and bring them into, I would say, not necessarily a stagnant field, but one that lacks innovation, and disrupt the industry. And that's pretty much what you're seeing in new space. And from SpaceX with their reusable launch vehicle to companies like Planet Labs and others in the small sat sector that are taking both hardware and software that's come out of the cell phone industry, the communications industry, the big data industry, and applying that to the space sector. So new space is about taking innovative, disruptive technologies and applying them in a sector that's been, let's say, reluctant to adopt those technologies. There are a number of good examples of this. We mentioned SpaceX, Planet Labs are also companies that are working on synthetic aperture radar. Those companies that are like Umbra Labs that are developing the hardware while at the same time allowing software developers to monetize the data. Many companies think they need to be vertically integrated. Is that true? Is that not true? I mean, that's its own decision. But I was in a discussion with some of the people from Space Capital saying, what things do you focus on as a company? And the things that are really adding value to customers, the things that are your secret sauce that you alone bring value to, are probably the things that you want to do in-house. And other things that perhaps aren't in your expertise, perhaps you can find a partner to make that work. There's kind of a push and pull between vertical integration and distributed company assets, and I would say it's kind of that decision's made on a case by case basis. But new space is fundamentally about taking disruptive technologies and applying them to the aerospace sector.
Mm-hmm. Absolutely. And having worked extensively in both the private and public side of things, both NASA and your work in the new space industry, do you see a point in the future where the needs of NASA and the commercial space industry diverge? Today they work very closely in tandem, very closely with each other, and NASA supports many parts of the commercial space industry directly. Do you see this dynamic shifting anytime soon? And if so, over what specifically would you project?
Yeah, I mean, I think the commercial space sector exists. When you're talking about commercial space, and for companies that aren't deriving all of their business from the government, they're providing a service to customers in the private sector. Those companies, if you go out and you're pitching your company, you really have to be able to assess what are the risks associated with the development of that technology. We've had 50 years of space flight, so there's certain aspects of the problem that are kind of known within the commercial sector. Therefore, it makes sense for when you're able to assess risk and you're able to assess what the market is, that you can build a company based on those two positions. Certainly, investors want to know what are the risks in this company, and then how big is the market. NASA will continue to exist because it serves the needs of government, serves needs of scientists and engineers, and it has a national objective. Their ability to partner with commercial companies is important, much like how the government partners with the commercial sector in many cases. It's probably important for a government not to duplicate what can be done in the private sector. I mean, that's kind of a unique aspect of how business works in the United States, that we feel that commercial companies should have the opportunity to provide services both to commercial customers and government customers. But for those cases where we can't assess risk, where you kind of don't know what the downside might be, those are the kinds of projects where NASA should take the lead. For those projects where NASA has experience based on their past accomplishments, it's important to get that experience out of the government and into private industry. I think we all benefit we all benefit from that. So I see it, there's a sort of a symbiotic relationship that will always exist between government and the public, government and the private industry. And it's important for the government to embrace what the private industry can do. And it's important for private industry to work with government to achieve those things which, we find difficult to accomplish and kind of stretch the imagination.
Understood. Yeah. Understood. In your 30-year history, watching the commercial space industry develop alongside NASA, what most excites you and what most frustrates you about the current state of the space industry and maybe where it's headed as well?
Yeah, I mean, this is as you say, a very exciting time. I liken this to how aviation developed throughout the 20th century. The beginning of the 20th century, we had a rudimentary understanding of aviation. And at the end of the 20th century, you could easily get on a jet aircraft, buy a ticket on a moment's notice and fly halfway across the world to a destination which, previously would have taken a month or more to get there. 20th century also excelled in developing communications. The kinds of innovations that we saw in the 20th century will be similar to what we see in the 21st century, and certainly within the aerospace sector. We've got 50 years of experience of building and launching satellites. We've got 50 years of experience of human spaceflight. And now's the time for expanding, taking that government experience and rolling it out into the commercial sector. We've seen a lowering of the barrier to entry, which allows entrepreneurs to come in to that sector with a lot of innovative ideas that probably haven't seen their time in the sun yet. And this is what spurs innovation. It's when you have a lot of people participating in space, and it's not just the space flight participants like on Virgin Galactic, buy your ticket and get a suborbital space flight, or maybe with Blue Origin get an orbital space flight, or SpaceX later on. But I think it's the business of space. How can you use space as an asset for building and growing a company? We've seen that in the small satellite sector. We're going to see that with regard to lunar activities. And when you talk to people in the mining industry, they say, you know something about the moon, but you probably don't really know enough. There's probably still more to understand before you go off and build lunar mining colonies. But that's a big opportunity to the extent that NASA provides the direction and, of course, the funding for making that happen. That's going to be a big plus for lunar growth. We see the same thing in LEO with the funding of a number of early stage companies to build habitats in LEO. We've got robotic missions. We've got tremendous economies of scale when it comes to AI and robotics. And how will we take those economies of scale and apply them to the space exploration vertical? And I look and say, pretty much the next 20 years is a very exciting time for LEO, human space flight in LEO, the return to the moon, also within the next 20 years as a return to stay, and clearly within the 21st century, the expansion of technology to broaden our understanding of Mars and robotic vehicles. I mean, NASA's been tremendously successful in fielding a number of robotic vehicles to explore the surface of Mars and understand the origin of life in our solar system. So, life here on Earth, right? But which is a big, somewhat of a mystery, right? I mean, why is life here on Earth? And you've surveyed the other planets, you can see how inhospitable they are. But for Mars, what's that 4 billion year history of the potential for life on Mars? Did life ever exist on Mars? If so, why? If not, why not?
Mm.
And then, of course, as we look at other NASA missions, doing the exploration out to, the survey of planet-forming systems in the immediate vicinity of our solar system and, throughout our galaxy. Very exciting topic. So, I think by the time we get to the end of the 20th century, we should have, a combination of both robotic and human presence on the moon, some sort of combination of those two on Mars, and then a much deeper understanding of how habitable planets, the number of habitable planets, the number of Earth-like planets in our own galaxy, and then how many of those, possibly are reservoirs of life. So, we'll fundamentally answer a number of questions that, we've been asking as a civilization for hundreds, if not thousands of years, and all of that, within our lifetime.
Right. And the most frustrating part about the current state of the space industry and maybe where it's headed.
That's the positive side. I would say if you really want to get frustrated, talk about trying to please customers, right? And I think that's an important aspect for the new space sector. It's not about the technology, and it's not about all the things that get you excited, but it's about really saying, what do my customers want, and how to serve them properly, how to acquire customers and how to retain them. And, sometimes, if you've got a lockdown on the industry, are you really serving customers the best way possible? And I think a lot of companies struggle with that whole notion of customer acquisition and customer retention. How do you really understand, walk in the shoes of your customers and develop a product that meets their needs? And here in Silicon Valley, we talk about, is it an aspirin or is it a vitamin? Vitamins are like nice to have things, but what you really need is you want to find out what are the pain points. Where does your customer need an aspirin? And that's what you're going to give them. So, and that, you've got to work hard, and it's not just sitting in your office and thinking about what the customer problems are, but engaging with customers. Scientists and engineers are known for, great, feats of cerebral achievements, and less so for being outgoing and interacting with everybody. And so I think that's a very important aspect of the new space sector, is how do you identify what are customer problems, and then how do you answer, create a product that answers those needs. So, if anything, within new space sector, I think this is something that we've all got to do a better job of. You see it all the time, when you're shopping in retail, or, you're going to fast food, there's always an emphasis on customers, but we have to bring that same customer focused mindset to the new space sector.
Mm-hmm. And building off that idea of cultivating a mentality of customer value above all other things in the new space industry, where would you say the opportunity in the new space industry is today? Launch companies are the most flashy and get some of the most attention, but is there an opportunity in a more specific, maybe less flashy part of the industry that people tend to overlook, but is going to be both a very impactful and lucrative player in the near future?
Yeah, well, launch companies lower the barrier to entry to space. And, with companies like SpaceX, you're seeing the price point come down for, the cost of getting 1 kilogram to orbit. And this gets back to the early question of, like, what is new space about? New space was that all of a sudden the space business was something that was compatible with Silicon Valley investment strategies. In Silicon Valley, when you're starting a company, you're going to go through tranches of funding, and each tranche of funding is intended to mitigate some risk of failure. customer acquisition, customer product fit, expansion of the business, and the lowering the barrier to entry to space and technologies that have large economies of scale kind of put the space business into the realm of what you could do with a Silicon Valley type startup. And by that I mean that for $600,000 you could demonstrate some level of success with your technology for ground-based applications. For a couple of $1 million you could build and launch and deploy your satellite and operate it in orbit. For tens of millions of dollars you could expand on that concept and fly tens of satellites and so forth. So what happened is that space started to fit the Silicon Valley model that has been successful across many other verticals. Again, reflecting back on where is space going to solve these problems? You've got to if you're an entrepreneur and you're thinking about, hey, I'd like to start a company, you better go back and say, well, what are the problems that exist where space can be a solution to that problem. An entrepreneur doesn't have to focus on space, but space is an asset which is accessible within the funding model of Silicon Valley. A great example of that is a company like Orbit Fab, with Dan Faber. Where Dan is focused on kind of refueling of satellites in low Earth orbit. We're seeing the adoption of satellites with propulsion technologies. As you start talking about more satellites flying in low Earth orbit, you've got to watch out for collisions. You've got to be able to maneuver your satellite. Well, what does that mean? That probably means that propulsion technology is going to be important. When you have propulsion technology, well, tell me about the fuel that's associated with that. I mean, some of those are markets that have yet to be developed, but I would say if it becomes obvious that you should be addressing that market, it's probably too late, because if it's obvious, it's probably obvious to you and a lot of other people. We've seen that with Earth observations. 10 years ago, the Earth observations were dominated by a few very large companies, and Planet came in and said, hey, if we use small sat technology, we can, observe the Earth on a daily basis. And when you're doing that, what do you actually see? We've never had the opportunity to take a snapshot of the planet on a daily basis. And so there's a certain aspect of what happens when you build it and you start to see things that otherwise you never would have expected, which is part of the science of it. But then again, they can do it at a price point which is attractive to a Silicon Valley investor and to customers. So we mentioned before vertical integration. I think Planet has kind of rethought their model and trying to invite more people in to help do that last mile of answering customers for questions. They've got a huge database. How do you use the Planet software to turn the crank on the data and answer questions to customers? So, where are the opportunities? We've got a huge, what I would call tsunami of Earth observation data, which is capable of answering questions for farmers, for investors, for retail entities. I mean, here we're living in COVID, but I think at some point the economy will bounce back on these things. But you might say, how can I take all this data that exists from both private and government satellites and synthesize it into a product that adds value to customers, that customers are willing to pay for? In that sense, Earth observation data is a big data play. It's a big data play, much like anything else. And so if you're doing data fusion, it's not just data fusion with Earth observation data at one wavelength or another, or imaging versus synthetic aperture radar, 3D point cloud data, but then also how do I include some of the other big data? that's out there, big data coming from social media outlets, or big data that's coming from economics, of data that's going in and out of harbors, um, and it's tough to cover all fronts of a very broad ecosystem. And I think it's an opportunity for entrepreneurs to come in and say, I understand this industry well, whether it's the insurance industry, whether it's the um, retail industry, whether it's the real estate industry, and say, all of this data that's coming in from space, how can I use this to better serve the needs of my customers? You know, all entrepreneurs and all investors want to know, where's the next big thing? And as anybody, if you had the answer, you know, would you be doing what you're doing today, or would you be off pursuing that? So I would say, aside from the answers, is what are the, you know, in science, what matters is not, in part it's the answers, but sometimes the breakthrough in science comes from asking the right question. And again, the right question is, what are the problems that customers have that can be addressed by the data and the assets that are available in space? How can you use the microgravity environment to, you know, produce products that otherwise you can't produce, you know, in a 1G environment here on Earth? I mean, how can you take the technologies that have large economies of scale, as I said, like AI or robotics, and apply that to the space sector? If you're looking at, you know, what we did going to the moon in the 1960s, we live in a completely different world today than 50 plus years ago. We have a whole different suite of technology tools that we can apply to these problems. And, you know, I think if you look at robotics, self-driving cars, the technology that makes self-driving vehicles possible, those same things, you're like, how can I apply this to the aerospace sector? How can I apply, you know, numerical modeling techniques to the next generation of vehicles? How can I take the advantage of Moore's law and the incredible processing power we have and apply that to the analysis of big data, to real-time problems, and make decisions, you know, on the fly. So, I mean, I think that's what makes this time so exciting, is that we have so many technologies that are capable of solving so many big problems. It's worthwhile for entrepreneurs to pause and say, what are the big problems? And then how can I go solve this with the technology that's at hand?
Right. Right. Absolutely. And our final question: as a former NASA airborne astronomer, was there any project you specifically worked on or revelation that you came to about the universe through your work that gives you pause, or some piece of wisdom that you've always carried with you?
I think this is a more of a statement about our time here right now. I like to joke with people that given the New Horizons mission and the Pluto flyby that we've done, we've kind of completed the marketing survey of the solar system and determined that the largest markets in our solar system exist here on Earth.
Right.
You know, you haven't been able to really find, you know, lots of life elsewhere. You know, other parts of the solar system are pretty uninhabitable. I mean, there's, you know, it's difficult. You know, it's difficult to exist in Leo. It's difficult to exist on the moon. I mean, all those are big challenges. And I think the 21st century, aside from being an exciting time, is also an inflection point. You know, we're looking at things where you know, as I say, evidence-based reasoning has been the hallmark of the Enlightenment, you know, for the last couple of hundred years. And, you know, if you're ignoring the evidence and making decisions in the absence of what science tells you, that's probably not a good thing. It's probably the wrong thing to do, and I would say it's probably regressive, and it's pushing us back to times that we probably not like to return to. So I think it's for everyone's benefit as we deploy new technologies and we look at the problems that are facing the planet as a whole, that we probably tread very carefully, because the consequences of our actions in the 21st century are likely to have ramifications for many, 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 many generations to come, and for many, many people, some of which haven't even been, many of which haven't even been born yet. So, as a scientist, I mean, I approach much of what I do as a scientist and say, well, what's the reason for doing that? Or if I had that piece of data, what would I do differently? And we seem to live in a time where people ignore the data that's there. They ignore the predictions of scientists, which I believe is probably not a good thing. So, but this will be one of the most exciting and challenging centuries for us to face collectively as a planet. We have a great place to live. We should keep it that way. We've got a lot of places to go. We've got an entire solar system to explore that will provide us with conundrums that we otherwise would never have anticipated. And those things will only occur to us by being there and by asking questions and seeking answers. So, for the group at Georgetown, I think you guys are in an ideal spot to position yourselves to be impactful players in the new space sector. We've been talking about science and engineering. It's also about politics. It's also about sociology. All of these things come to play in the new space sector. And, I think your group is doing its part to engage new minds, to ask new questions, to find new answers in the 21st century. So I applaud your efforts and certainly welcome an opportunity to work with you in the years ahead. So.
Absolutely. Absolutely. Well, Dr. Casey, it's been an excellent conversation. I really enjoyed it, and I hope everyone watching finds it as valuable as I did. Thank you so much. Really appreciate
Thank you very much,
lending your
Eric.
time today.